Hi all. So this is the autograph project. This is what my dissertation and research has been on, and this is a working demo of how it works and what it does. So you can see the idea is as simple as what has been shown on the landing page. Think of it like a funnel where unstructured data goes in and linked data comes out on the other side. So how it happens, we'll explore this in a minute. So once we click on this Explore Web App button, we are prompted with four features. So first I would like to show you the knowledge graph that we have already built and is existing inside of our database. So as you can see right now, the nodes have been limited to 25, but there are 562 nodes and 678 relationships in this database. We click on this and we can see the entire graph. And let me explain this graph to you a little. So as you can see, there are clusters of every patent that we have ever passed and loaded to this application. Each yellow node represents a product that has been protected inside of a patent. So products are what we are trying to find on the websites also, that will contain patented chemicals, and product is what has been protected inside of a patent also. So basically a cosmetic patent will basically protect a patent and its composition, giving the different type of weights and different types of usages that are present inside of the patent. So what we have done is we have divided the graph into two subgraphs. Let me go a little bit more deep in this. So one you can see is the websites subgraph, and other is the patents subgraph. So the subgraphs are in black. These are the starting points. You can think of these as the starting points of this graph. Whenever we want to query the graph, so we will target our query based on these subgraphs basically. So if we want any products that are present inside the websites, we will query the website subgraph, and if we want products that are patented inside patents, we will query the patents subgraph. Now patents is basically a list of different types of patents that we have loaded inside of this subgraph. As you can see, the blue is actually a patent node. So you can see it carries the following information: the patent number, the CPCC code, that are the similar patents to this patent, created at, inventor name, and the assignee of this patent. So now this patent protects this product. This patent using this link relationship protects this product. So ID is 392, advanced antioxidant skincare serum, description, a small description of the product that is patented inside of this, that is protected inside of this patent, and type of the product. All of this information has been extracted using LLM, and the format has been specified. The schema has been specified in what schema you want to uh, basically insert this information into the knowledge graph. So you can see this is one of the patents. If we go to another patent, it will show us the inventor names and the assignee and CPCC code. For some reason there is no description in this patent, but there should be a description. There might be something wrong. So this is like again a patent which protects this product. So product has description, patent doesn't has description. That is why it doesn't have description. Patent does not have description. Products, the products that are protected inside of the patent, they have description. As you can see, this product has been protected inside of this patent. So this product has a description of anti multifunctional sunscreen and cleansing system. So you can see that all of this graph has a proper structure associated with it. And right now we see that based on the similarity, these graphs appear closer to each other based on different type of chemicals they share and based on different type of properties they share. So all of that. Now how do we insert a patent inside of this knowledge graph? What we do is we go over here and we click on unstructured import. We click, and here I have some patent samples. So we open this patent, and we can see a PDF version of this patent. As you can see, there's a lot of text for us to process. Now we first go and we check that is this patent already present inside of our database or not. So we copy the patent number, we go over here and we explore chat with knowledge graph. So chat with knowledge graph presents you with two options. You can either use a local LLM, Llama, for chatting, which is running on my local machine, local Mac machine, and you can see that it doesn't take that much memory and anything. You can use Olama or any Olama index or any other type of library to run a LLM locally. So you can either use Llama, or even you can use GPT-4 Mini, which will cost you nothing. And right now there is also DeepSeek in the market. I'm going to update this to use DeepSeek, which will become next to negligible. So for all testing and prototyping purposes, the cost will be, you know, congruent to zero. It will be next to zero. It will be next to $0. It will cost you nothing to train this. So I enter the patent number and I ask it, is this patent present inside the database? So as you can see, it has responded. The patent is not present inside the retrieved database. The database contains several patents, including these. Which patents? It is showing you. So we can also ask how many patents are present inside the database, and it will tell you how many patents are present inside the database by reading this graph, by querying this graph. So you can see there are total 6 patents, and it is telling you patent related information about that. It is not going into detail right now. So what we can do is, now we can add this patent, as we are sure that it is not present inside of our database. So we again go to this and we go to unstructured report, and we click on this and we go to patent 18, we open, and this was not present inside of our database. So once I click on this view text button, you can see the entire text of the patent has been given to me. So I have converted the entire text of the patent into PDF text into normal text, which I can use to create chunks of this text and give it to the LLM in a fashionly manner. Once I click on the load patent button, so you'll see some more relationships being created and more nodes being created. Basically, we should have another cluster being created in this knowledge graph, that another cluster that will be associated with the existing nodes in a proper schema and everything. So these numbers should go up, and then we will chat with the knowledge graph using our old local LLM, and then we will show that there are now not 6 but 7 patents. So once I click on the load patent button, it is loading. Now this is going to take some time. So just to show you how the processing goes on, this is the Docker container logs. So what happens is, role information extracted. So I have done some prompt engineering to provide proper prompts so that relevant information is extracted, and chunk by chunk the information is sent. So you can see, once we click that button, process started with patent text. Number of chunks created were 23 chunks. So from this text, 23 chunks were created. Processing chunk number 1, total sent for chunk number. So we are token sent for chunk 1. So we are also keeping count of the tokens sent, because if we send a lot of tokens, then it will just not make sense and it will not give correct outputs. So this is the relevant information we are extracting from the relevant chunks. We have extracted the information: patent number, inventor name, assignee information. All of this will be present in the patent node, as we saw. Sending request to open, then you can see that so this is the response that is received. So based on the functional role of a chemical, we have classified all the chemicals. There is a very generic classification that needs further explanation that I have used to classify these chemicals and associate them to a product basically. So a product will have different functionalities. For example, a cosmetic product can have conditioning functionality, or it can have nutritioning functionality, or it can have you know any kind of functionality. So based on that functionality, which chemical is providing, is basically contributing to that functionality, we have encoded that functional role. Based on that information, we can find similarity in this and then proceed. So you can see it will go chunk by chunk, and it will try to find similar information, and it will just keep on going and keep on going. And imagine all of this costing you nothing. So you can see it is right now on process chunk number 17. So it's about to complete. So once we can see that once the JSON object has been formed with all the information, chemical information, we can see all of the information has been, using Cypher query statements, it has been merged inside of the knowledge graph. You can see there are a lot of queries made, and chemical query results successfully executed. Now technically we should have, so we can see the relationship numbers have increased. Earlier it was 562 and now it is 635. So now we'll go and see the bigger graph also, so we can compare. So as you can see, something has changed in this. A new patent has been added and a new type of cluster, but this also remains a problem, like how to identify the proper boundaries of the cluster. But we can be sure of this patent that has been added by using the chat option. So once we go back and we click and we go to chat with, now if I ask, is this patent present in your database? So as you can see, now it is showing that yes, this patent is present inside of our database. So we can ask for further information also. Give me complete analysis of this patent. What kind of chemicals it has and what type of usage it has. Again, you can see the Docker query logs. So here you can see, give me a complete analysis of this patent, what chemicals it has. Based on that, it has queried the knowledge graph, and you can see that this type of information has been presented to us. So you can see here is that information that is missing. So first what it does is it give me the complete analysis. So what it does is it figures out which query to use. Now it has used a query that will give me the complete patent information from the knowledge graph, and so you can see related to that in all the information other glycerides has been summarized and presented to us. And here we can see the patent US pertains to a cosmetic product known as advanced emollient skin treatment. This product is designed primarily for emollient and emulsifier, which are SS. You can see the entire information of that patent has been presented to us. Also, we can in a similar fashion, the products that were scraped from the website have also been inserted into the same knowledge graph. So the smaller parts of this graph, like this, so you can see that websites, right now there are two websites. Trigain official store and yesstyle.com, from which we have scraped the products. Now from Trigain we have scraped this product, Trigain caffeine shampoo, and from YesStyle we have inserted this product, Beauty Cheeks High. You can see this Beauty Cheeks 3-in-1 contour palette, and it has the following chemicals. Using a similar approach and a similar button that we have for loading the patent data. So if you click on this button, it will load one item from the scrape data automatically inside to the database. Right now there is a scalability problem in this system, so it contains how many website offered products are in your database and how many chemicals are in your, how many patents are in your database. So based on the question, our query will change and it will fetch the relevant information from the knowledge graph. So you can see how many websites. Based on this, some processing, some prompt engineering happens, and you can see, to summarize, there are 3 products. And why is it saying 0 patents? Because it was not able to fetch the patent information, that is why it's saying. No problems, we can see that we can query it individually, how many patents are there in the database. So this is what we have to further optimize. Depending on this natural language queries, these should be converted into proper cipher queries that can query this knowledge graph for information. Query this knowledge graph for information. So you can see that there are total 7 patents now. Earlier there were 6 patents. Now there are 7 patents and 3 products. Now based on any of the 1 patents, the idea is that right now there's a brute force approach, but we need to optimize this also in the further research, but technically it will work. So if we choose this contour palette, tell me about the complete analysis of the chemical used in this product offered on a website and the patent in your database. How similar are these two? Now based on this, it will query the knowledge graph specifically, gather information about the product and gather information about the patent. So if I may show you also what it queried and how it, so you can see that all of the information that it needed. Using this query, it got information about the patent, chemical composition. Using this query, it got the information about Trigain shampoo, product name, other product names, and based on all that information, it can generate a similarity score. So to analyze the similarity between this patent and 3, we will compare the chemical functional roles of the both: patent analysis, product analysis, screen treatment. Now the further idea is that this analysis will go in this report generator column, and for every patent a functional role column will be, graph will be generated, and a chemical analysis over here, the extracted products from the websites will come and their functional roles will be mapped. This will be an iterative and brute force approach. Right now patent will keep coming, the product will keep coming, and they will keep being matched for similarity. If there is similarity, it will pop up and show you that whether that specific product is worthy for further investigation or not. But as we saw that there is complete analysis, we have complete control of this database. We can delete and insert patents as we want. One of the last features that I would like to show you is inherently by its own, once you do this much, if you select a Chinese or some different language patent, then also if I click on this load button, just before clicking on that load button, I would like to so just to end things, I would like to show you one just to end so just just to end things, I would like to show you one more feature that this system inherently got when I built it like so. So what happens is this is a Chinese patent. Now when I convert it to view text, all of the Chinese text that was present inside of this patent has been extracted, and now the API is accepting the calls. So once I click on this load patent, it will start analyzing the Chinese patent also. But due to some string manipulations, and because it is complicated Chinese text we are talking about, Chinese chemicals we are talking about, some string manipulation will go wrong and it will not be able to formulate the final JSON object on this. But technically speaking, the analysis is running on this Chinese version also. It's just some string manipulation that I need a little bit more time with to fit it into a proper structure so that it can be inserted into the database. But right now we will see that it is analyzing Chinese information also. So once I click on this load patent button, you can see that it has sent Chinese chunks and it has extracted information. So patent number is this, patent name it could not extract, 26 chunks were created. No, inventor name, it has been, oh, so that is the format, oh sorry, that is the format, this is the information. So patent number has been extracted, inventor name in Chinese has been extracted, and these names mean something. So if I copy this and I take you to Google and we convert this Chinese to English, we enter. So Ma Ching Wang Zhu Zhu is the name of the person that invented Ma. So these are two names, sorry. These are two names. So Machi. Okay, so Machi, Chinese inventor. Let's search if something is popping up or not. Nothing is popping up technically, but as you can see that it is not, the system is not completely rejecting the response. You get me? We still have interpretations without doing almost nothing for it. It has this feature built inside of its own. So you can see the resveratrol is the meaning of this. If we convert this to English, what does that mean? Polydatin. So this is one of the patented chemicals that we are looking for. So you can see that it is recognizing Chinese patents as well. Resveratrol is, I think, a synonym for polydatin, and polydatin is one of the so as you can see, this is the C database that was given to us. So we can see that in this patent, polydatin is a claimed ingredient. This is the future bit patent that I extracted. So you can see that technically it is extracting relevant information from that patent. So you can see that this Chinese patent that contains the future bridge information, this resveratrol is present in 0.1 to 20% in the patent, obviously. So obviously it is supposed to be in the patent, but it has been, you can see that Chinese information has been decoded completely and is still going on. Now I've already run this on in my code, and I have a backup for this. So you can see that this cosmetic Chinese product has been extracted from this kind of workflow. So as you can see, this is now a multilingual model and everything works. in a brute force manner. Obviously, that part is left, how to make it scalable. But yep, this was the demo of Autograph. Where is it? So this was the demo of Autograph. Please let me know if you have any doubts and problems.